Hi, I'm Anthony Stillman, and today I'm going to be starting my R for laboratory work videos. To contact me, it's Anthony Stillman at 313@gmail.com, and contact me if you have any questions. So, what is R? R is a programming language that is very specifically used to mostly run biological and molecular data. It's somewhat narrow in its aspect, but what it does very well. It's a specialized tool that works really well. Here's the syllabus, but this is not what we need right now. I need this. So R has this site where you can download a version of R for free. Hit this download link, and there's various ways and links to download it. Like this, one of the links, and then you download whatever version you want. There is multiple different versions. There is Linux, Mac, and Windows, and you download that. So you click on it, and then it's gonna be installed for the first time, and you click on it, and it will download. I'm not gonna click on it because I already have R on my program, but you should just make sure when you're choosing one of these places to download from is that you choose an area that is close to you so the download can be done quickly. All right. Same thing again. Anyway, now that you have R, let me just bring up an R really quick. Just R in itself is very the R program itself, you can code on it, but it's not very effective. A lot of people use like shells to actually run it, including myself. I use RStudio, which is also free. So you go to R postdoc downloads RStudio desktop, and then you can install RStudio. It's gonna download. Very straightforward. It's gonna ask you if you want the professional version or like the non-professional version. Just pick the non-professional version because the other one you have to actually pay for. I gotta go through it. Now I'm actually gonna uninstall it. All right. So once you have both R and RStudio, you can launch R, which is this program, and it works really well and it's very clean. And we'll get back to this in a second. I need to cover some other things really quickly. So when you're running R, R has various tools, packages they're called, which you can use to analyze, manipulate, or affect data. And there's a package library on the CRAN website, and CRAN represents means. Should forget off the top of my head. Oop, not that. It's the current R archive network. I think that's what it means. What CRAN means. Oh, I forgot. Anyway, so the packages you can use are all listed here, and you can install them into R directly or into RStudio directly, and they have little descriptions of themselves. So you can see there is a lot of tools R has available to work with, and these videos are going to show you the most basic ones that are useful for lab work and analyzing lab data, molecular lab data. Another library that's like CRAN is Bioconductor. We're not going to cover this until like toward the end of the classes, but Bioconductor is a very focused um, uh, group of packages for running various data. Like you can see here, this one's like biogenerics S5 generic fusion using Bioconductor. It's a very specific packages and code that you can use to run R. But not least, a lot of the stuff I'm going to be showing you today is also inside the W3 Schools. This is a great resource. I'm going to cover most of all this and then some additional things I find useful for understanding the basics of R. But if you want something to read instead of watch and something to refer to easily, this is a really good resource. And all these links are inside the syllabus. And now with that out of the way, let's actually get to the RStudio and coding. So this is class 1, and we're just going over basic R. These are all the links I just went over with you. And then some YouTube link about how to install R and RStudio. And then here's the link to the basic classes and a useful video I found. So if you want additional videos, they are peppered throughout these classes. And so this is RStudio. And you can see it's like any other like modern computer program. You have file, you have edit, and you can do various things. The main thing you want to focus on is that this is where you write the code. And then here's the console where the things that you actually run populate at. And then over here, you can go over here to install packages. So like, let's go here. Let's go to packages, install. And you'll have to do this a few times throughout these lessons if you don't have these packages. And let's just do numpy. Let's do ggplot2. Just do ggplot2. And then it just downloads. Yeah, it just downloads the package where you can see down here. All right. And then this is the plots. This will be very relevant later, like the plots you can show. And up here are the objects you're creating. So I'll talk about more of this when we're actually using it. Talking about it now is just kind of confusing. But another thing here is that all these have brooms near them, and the brooms allow you to clear data out without like closing up R. So I can just like hit this little broom. It's hard to see, but it's right there, and it clears out the whole console. So if you want to like reset the console so you can see what's going on and not see a bunch of clutter, that's wonderful. And I do it all the time, especially when I'm trying to figure out a problem because it's like there could be too much pileup of code, and it just gets confusing. All right, now let's actually get into running code. So the way that you run code is either you go up here and you just run it by clicking this, and it runs everything in all the code you have coded, all the R code you have coded. Or you can go to a section and then you put control, you press control and you hit enter. And you can see here is ran the code. So 5 plus 5, control enter, that part of that code is run. That's the basic of how to actually like execute code. Let me take a drink really quick. So now let's get into actually what you can do with R. First thing first, the basic thing is just math. R can be used as essentially a calculator, and this seems very basic right now, but later on you'll be able to use this to actually help analyze your data and organize data and so on and so forth. So learning these basics are very important for how to use R. So you can do addition. So 5 plus 5 equals 10. Let's actually clear all this before we start this. 5 plus 5 equals 10. Then let's do subtraction. 5 minus 10 equals 5. Division, 30 divided by 5 equals 6. Multiplication, 15 times 4 equals, you guessed it, 60. Then you got square, which is either this caret here or double star. So let's do both. And there you go. So squaring something, how you do a square root is that you write the function sqrt bracket bracket, And this is how most functions work. You write a function is essentially a tool that you use, something you call on to do something. It's like a little machine. And then you put something inside that machine and it gives you something else. It like processes that thing you put inside and like spits something else out. And so this is the first function we're actually encountering. And there's going to be plenty more that we're going to see. So you have this square root. We have 9 inside, and it spits out 3. And then there are these, which are not necessarily mathematical functions, but they are in the math sphere, and that's max and min. Max, you probably guessed it, will return the max number you have inside it. And then min does the opposite. It gives you the minimum. Very useful for figuring out a range of the data you have. Like what's the furthest and lowest in that piece of data. All right, and then you have absolute, which is another function. It's ABS, not brackets, but like parentheses, and then the value in it, and it just turns if it has a negative number in it, it will make it positive. Not it doesn't make it absolute. If it has a positive number, it does nothing to it. It just makes something absolute. Very basic stuff. And then let's get into the rounding functions. There are 3 types of rounding functions. There is ceiling, there is round, and there's floor. Ceiling is it rounds up always. It always rounds up. So even though this is a 1.4, you run it gives us 2. Round is like a normal round, like how you see it, use it in a normal day. So you round 1.4, it gives you 1 because it rounds down because it's below 0.5. But then you have round 0.5, it gives you 2 because it reaches the 0.5 threshold, so it's going to round up. And then you have floor, which always rounds down. Like, let me actually change this to make it more extensive. Floor always rounds down. So 1.8, it goes down to 1. Even though it's really close to 2, and it should be rounded to 2 if you're normally using our normal rounding logic, but since it's a floor, it goes down to floor. All right, that's math. And that's just a very, very like fundamental things about R you can use, and you're going to be able to use this later on for far more complex methods. All right, now we're going to get into data types. Data types are like what an object can be, and what is an object? I probably should explain what an object is. An object is a value. It is a number. It is a word. It is a letter. It is a Boolean function. It's a Boolean value, which is true or false. It's basically things that actually exist. They're not machines. They're like what you put in machines, which are functions. So let's get into. So the first data type or object or value we're going to talk about is strings. Strings are essentially a string of, what string? Say string again. Is a series of symbols that are represented as text. So, and how you determine that a thing is text is that you put either double quotes around it or single quotes. All right, so let's run that. Hello, hello. And usually strings are made out of letters, but they can have numbers in them. Like you can put 4 in here, no problem. No problem at all. Just put this. So basically string is a series of symbols, letters, or numbers, or other symbols inside quotations, either double or single. And we can use the function class. Once again, functions are little machines. You have this on the outside, the function, and then you put something inside it, and we're putting hello world inside there. And what class does, it tells you what type of data type a thing is. So it's going to tell us its characters, which is string. Characters is what they call it in R. I always forget that because I So using Python. So characters. So then we have numerics. Numerics are just numbers of various types. Points, big numbers, small numbers, whatever, just numbers. They don't have quotations around them, because if they have quotation around them, they'd be considered characters or strings. So they just stand alone and they're just numbers. And they can have points inside them. And also, there could be scientific notation. But we're not going to get into that right now. So let's write this. You can see this numbers, and then let's do class on this number, and it tells us numeric. And then we have integers. Integers are special because when there's a letter error, it declares this as integer. So let's look at it. L1, integer, 55, integer, and then 100L, just 100. And then we run it through the class machine, tells us what class it is, and tells us integer. So if you want to make a number an integer, just put an L behind it, capitalized L. And then there's more complex variables, characters, data types. And you can see here it's this complex. So it is an equation. It's not with a unknown. So it's just what it is. And we can see it's complex. Then we have logical, or also Boolean values. Booleans are true or false, and they can be represented through either the word true or the word false. Or true can be represented as capitalized T or capitalized F. There you go. You can see true or false, true or false. All right, now that we got through all the data types, basically we have characters, which are symbols with quotations around them. Numerics, which are just numbers. There's integers, which are a number followed by the letter L. And then there's complex, which are equations or other things that cannot be resolved by themselves, so they just represent themselves. And then we have logical, which is true, false, true, false. All right, now with that out of the way, let's get into print. Print is one of the mainstay functions in R. It is used to print things. So let's say that, we'll clear this out, give us a fresh slate. I just want to print hello world. So it runs print, and this gives us hello world, this displays it. This is very useful so when you want to basically see what your program is doing, you can put print functions throughout, and they'll just print values out. So if you want to okay, what is this? This is a little more down the road, but essentially you can make it print a value and see what it's doing. So printing makes it display whatever you were telling it to print down here. Let's remember that for now. All right, so we're actually going to dip a little bit into loops here. What a loop is essentially you're going to repeat this. Is a for, and then a piece of what you're going to run inside a function, and then brackets, and then the function actually inside the brackets is going to run. And for this example, we have x in 1 to 10. So basically this x is going to turn into 1 first, go through here, and then pre-printed, and then it's going to go again, but this time it's going to become a 2, and just keep on going, repeating. So if we run that, and first the x is going to be 1 because it's x inside 1 to 10, so it's going to go through the numbers 1 through 10, and then be printed. First one printed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So that's basically a loop and is showing how like you can use print inside more complex programming to essentially like check what the value is. All right, let's talk about variables. Variables are objects. So variables are essentially what you can assign objects to. So for example, let's say that we were going to assign John to the object name. All right. And now John, and the way that you assign it is either with a either a um, either a assign tool, which is like a assign symbol, which is a arrow with a line through it, or an equal sign. Sorry, I just got to slow down for a second because my power just went out. And you can see here, we're going to either an arrow to assign something or an equal sign. And then we're going to go here and we're going to assign John the name. And you can see up here, I was talking about before that this populates your variables that are assigned, and now you can see that now name is assigned to John. And you can see, and this is very useful if you want to like look at your data and see what's actually like what your program is actually working with, and if also it can show that it can be have been overridden. Because let's just change this to Joe, and suddenly this name is Joe. So you can override variables that already exist. Now let's continue. So now let's assign age to 40. You can see before that Joe was a character string, and now this 40 is an integer, is a number. It's a number, and I'm assigning that to this. So age is 40. You can see again is assigned. And now we're going to actually run name. And you can see name is now Joe. So you run name and it prints out name. So now name is actually associated with Joe and it will run. Now we print age and it does the same thing. And this is once again just getting at what I was talking about before, is that when you run the same variable again, it just kind of overwrites the other one. So be careful of that. Sorry, just trying to manage my situation. And then once again, age. You can see that age once again is overwritten. And you can, I've shown here that you can use equal sign or arrow. I prefer equal sign because it's more straightforward. It's one character and you don't have to do these little arrow things. And name again, it prints out name. And then age. And it prints out age. All right. So, and you go here, you can print name, and it just prints the name. And these are kind of synonymous with each other. Just having the thing in there or just having it run as print is functionally the same. And then we're going to we're going to go to num1 and see if we can even assign numbers to variable. We were doing that before. We're going to do it again over here. Run that, assign that to that, and then num1 to 5, and then that, and assign num2 to 10, and then we're going to actually add them together. And you can see here that now it's 15. It actually does the math. And then there's various ways to name variables. Usually it's either you just name it straight up, like my variable. You just give it it gets the name period, or you with like no gaps in between or anything to separate the words that you're calling it, or you can actually give it like between the words you can put a space, not a space, but not a space, a underline, which one presents a space, or you can capitalize the beginning of each letter, each name in the variable, each word in the variable, so then it looks like you can see like the distinction. Or you can just keep it all capitalized, or you can have or you can just have a number in the variable, but the number can never go before it, or you can just have a character at the beginning. That's interesting to know, but the more important thing is actually know what illegal variable names are, such as having a 2, having a number, not 2, having a number at the beginning, does not like that. Having a dash, doesn't like it. Having a space, doesn't like it. Having a underline at the beginning, doesn't like it. Or having a symbol like at. And you can see even here, my code is like upset with me, which is another thing about RStudio that's nice. Like it tells you if something's wrong, like this code does not make sense, it will not work. And you can see it's underlining like all the problems with this. And if I try to run this, it's gonna be like upset with me. Yeah, so he's giving me an error code like this does not work. What are you doing? And if I do that with like the rest of them, it will do the same thing. All right. And then the final one is that you can't assign like booleans to like a value. You shouldn't do that. So now with that all the way, let's do types of conversions. Types of conversions are, we'll get into it. There's types of conversions. So let's make a integer by assigning 1L. All right. And then let's assign a numeric to y as 2. So y will become equal to 2. So now x, you can see up here, x is now equal to integer 1. You can tell it's an integer because it has the L. And then you have y is now equal to 2, which is a numeric. But now you can change. There is a way to actually convert a variable or an object into something else, and it's using the convert methods. So for example, convert from an integer to numeric, or really just you can convert anything, any number into a numeric if you actually run it through as numeric. So let's do that. You can see here, a is now equal to just 1. And then let's run. And now let's turn the y into an integer as using the as integer y and assigning it to b. All right. And you can see here it's actually like assigning it's assigning the variables by alphabetical order and not by like the order they are made. So it makes it easier to find. All right, and then let's actually run this, and you can see here, you run X, and it spits out a 1, or you run Y, and it spits out a 2. It's hard to tell, but this is actually converting them into different things, which is useful if you like need a number to be either integer or a numeric when it's going into a function you've created or a different function. It is very useful, but in very niche situations. So I'm just showing you it, but it's not something you're going to be using like every single time you code. And we can then let's look at the class. You can see here now the class of A is now a numeric. Let's look at the class of B. It is now a integer. All right, now let's look at character formations. So, characters functions. And the first one we're going to look at is count numbers of characters in a variable. Let's just run this. So we're going to assign hello world to this string. And then you can see it's here now, hello world. And then we're going to use the function nchar. And it's going to down here just tell us how many characters are actually in that string. All right. Now let's look at the determining if something is a variable. So basically this is actually a logical test that sees if something is inside a variable. So let's just once again, hello world is string. No, not that. And then we're going to run this function right here, and it's going to tell us true because that is actually because h is actually inside. It's going to say true. Yes, this is inside the string, which is this. So this function reply actually it checks if the first object in it is inside the second object. So it's going to produce true down here. Let's do it again. It's going to produce true again because hello is inside the string. You can see it right here. It even highlights a bit, which is fun. But when we do this and we try to find x, which is not in this string, you can see it's going to return false. All right, that out of the way, let's talk about, let's go back up. Let's check in. Got a little lost there. Let's talk about booleans. So booleans functions are, you can test if something is true or false by using the mallet system. So let's see that, so like is 10 greater than 9? That's going to say true because this is a, so this is a greater than symbol. And then we're going to move on to is 10 greater or equal to 9? That's going to give you true again. So if you want to do true or greater, you do the greater symbol and then you do equal sign. And then if you want to check if some two things actually equal each other, you do double equal signs. Not one equal sign, double equal sign. Because if you do one equal sign, it's going to think you're assigning something. So on that, you can see it's false. All right. And then over here, we're going to see is 10 less than 9? It's going to be false because, of course, 10 is not less than 9. We're going to use 10 less or equal to 9. Once again, it's going to be false because it's not. But here's an interesting one. Is 10 and 9 the same thing? And the way that you test that is you do an exclamation point and then an equal sign, which is basically saying these is testing if these things are not the same. Is the opposite of the equal signs. It's testing if it's not the same. And it's true. They are not the same because 10 and 9 are not the same. And you can do this with assigned variables. So let's assign A to 10 and let's assign B to 9. And now let's run, is A greater than B? So we're really running A, which is 10, and B, which is 9, and seeing if A is actually greater than B. Run that, and you can see that it is true. A is greater than B, because A is equal to 10, and B is equal to 9. All right. So we're going to, I'm going to take a drink. We're going to talk about if statements. And if statements are basically, it's a form of Boolean test. So you put an if here, and then you do what you're testing. And if this testing is true, then it will actually go through it will do the code in these brackets. All right. So if this is true, do what's inside the brackets, whatever function inside the bracket. And then to round it off, you have this thing called an else. And basically, you don't have to have else there, but else is good to have there because if does not trigger, you immediately go to else. So let's run this, and it's testing if B is greater than A, then print B is greater than A, else, so if does not trigger, else B is not greater than A. So let's run this, and you can see that it prints out B is not greater than A. All right. So let's actually go down here, up here, and let's assign B to 11. All right, so now B is 11. We'll run this again, and since B is greater than A now, when this runs, the if statement will trigger. So if B is greater than A, and that is true now, it will print out B is greater than A. It will not go to this else statement. And there it goes. It does do it. Okay. So that's the basic if statement, and that's as far as we'll go into that right now. It is part of the Boolean family, so I wanted to cover it briefly. And how you use Booleans and actually running code is actually you can actually make a program only run if something is true inside the values you already have. So let's look at our logical operations. So a logical operation is either a and or a slash, which represents or. And the and is element-wise logics and operator returns true if both elements are true. So T is true, T represents true, and the other T represents 2. So I run this, true. All right, now let's run a false and a true together, false. So when there's an and, if one thing is false, all of them are false. All right. All right, so now we have this element-wise logic or operator returns true if one of the statements is true. So this is the twist on it. So this line represents an or. Let's do true, true. It returns true because it's only one available. But then we run false true. And last time we run false true with the and statement, it returned false. But here it returns true. Because if there's one true in a or statement, it returns true. So in AND statements, if there's one false, all false. Or statements, if there's one true, all true. So AND one false equals all false, or one true equals all true. Just to jump back into the if-else programming. So if-else indents are key to this. You got to make sure that this is indented here. You can see there's little gaps. So anytime you have one of these, you have to actually indent it. There's an indentation that will naturally occur that shows that this function here is subordinate to this if statement. And that'll happen a lot more as you go on. The indentation shows like, okay, this is actually a sub function of something else above it that's not indented. Now let's go through the if chain. So let's first assign A to 200 and B to 33. And an if chain is, we already did this a little bit up here, but we're just going to do it again. We're going to add another element called else if. And so you initiate this chain with the first if, and then you run it. So it would be if B is equal to A is greater than A, print out B is greater than A, which is not true, so I won't do that. And then if else A is equal to B, and it'll print out A and B are equal to each other. And then an else statement, which is whatever is left in the situation, which is A is greater than B. And the thing about this is that the if chain is basically a chain of beginning with an if statement and then having your first Boolean test followed by whatever function you want to run if that Boolean test is true. Then you have an else if statement, and an if else statement is if the first if fails, it goes on to the else if and runs it. And if this else if statement fails, it can either continue on to an else that kind of like cuts off the chain that's the end of the chain, or you can have another else if statement. So the chain is if begins with an if and then has as many else ifs inside the middle part, and then it ends with an else. So let's run this. And you can see down here, A is greater than, it's going to go through here and show that B is not greater than A, so it's going to skip this. It's going to go to else if. A and B do not equal each other, so it's going to skip that. And then it's going to get to else, and else always runs if it gets past these first two, or many of else if, and let's run this, and I programmed it to say A is greater than B because there's no other explanation of why it's gotten down here. So let's now actually turn this into 200. Let's turn B into 200 and then run this again. You can see that now it's saying that A and B are equal to each other. Interesting, because it's getting to here. B is not greater than A. Does not go through the first bracket of the if statement. And then it goes to if else. It tests if A and B are the same. They are, so it prints out they are the same. It runs this code in the brackets. Finally, let us do this, which is assign B to 201. So now B is actually larger than A. And just run this. And you can see here now it's printing, it's going through here. B is greater than A now, so it's going to run the if statement part of the bracket code, and it's going to be B is greater than A. This prints out here. So let's briefly touch on nested ifs. So you saw, I told you before that indentations are important. So you can see here, let's sign this. You can see here that if is greater than is testing if x is greater than 10, And if that is true, it's actually going to go into its brackets. But then you can see here that the brackets that contain another if statement. So the if statements are they are nested. All right, and then you have an else at the end of the if else chain. All right, so you can nest ifs inside other ifs, so you can like have multiple tests to see what it's doing. So let's actually run this, and it's gonna be like it's first gonna go through here, print else, print above 10, which it is, and then it's gonna print it's also above 20, and then it's just gonna run out, and it's not gonna hit this else these two else statements because both the ifs are satisfied. Please turn this to 12. Reassign x to 12, and then run that again. You can see here, now it's going through here. X is greater than 10, so it's going to run this above 10, print statement. Then it's going to go to F. Test F is greater than 20. It actually isn't, so it's not going to run this bracket part. And then else. And then since this if is not running, it's going to print this else statement, which is not above 10. All right. So that's how you nest if statements. All right, well, now let's talk about AND. We talked about before that AND can be used as like essentially to sum up multiple Boolean results. So if all the Boolean results are true, the AND group is true. If one of them is false, they're all false. Just a little refresher. So let's assign these three values really quick so we can do this. So then we can see here this if statement, instead of just testing one thing, it's testing both these things. So it's both testing is A greater than B and is C greater than A. And if both these functions, if this is true and this is true, this will indicate it will return true and the if statement will run because of this AND statement. So let's run that. And you can see here, you can see here is that it is true that both conditions are true, which is that A is greater than B, but A is smaller than C. All right, so you can have multiple. Let's change this to 99, which will reassign C to be smaller than A, and then run this again. And it's going to not return anything because it's not true. All right. Continue on to, now let's do the same thing again, but this time we're using the OR statement, and once again, or if one value is true, they are all true. So only one of these has to be true for this to run. Let's run it. And it runs as true because both of them are true, but not both of them don't have to be true to run it. Let's go 99 to assign this, run it. And now even though this is false, this is returning, this overall is going to be true because one of them is true. Looking a little ahead. So now we're going to look at loops. So loops are like if, but they continue to run the code until it is false. So let's assign I to 1, and then this function is going to run. It's going to, as long as I is less than 6, it will continue going, keep on repeating itself. So we're going to run this function, and what's going to happen is going to first it's going to print I, but then it's going to add 1 to I, with this function. So 1 plus I plus 1 equals I, so it's going to reassign I as like essentially 1 more than it is currently. Run this, and you can see that it is running, it's just counting to 5. 1, 2, 3, 4. Whoop. Not mean to do that. 5. Because what's happening is I is going through here. I is being printed as 1 first, and then I is being turned into 2 by being added, having it added by 1. It's going back through the system, and it is now 2. 2 is still less than 6, so now it's being printed again. 2, repeat, 3, 4, 5. Then then finally hits 6. When it gets to 6, it goes up here. 6 is not less than 6. So now this statement is false, which means that this while statement is knocked out. Okay. This while statement is now going to cancel itself out because the statement essentially allowing it to run is false, so it stops. As I talk about breaks, breaks are a function that allows any loop that's happening or if statement that's happening. If you hit it, it just kind of just bounces all the way out. It's not really recommended to do because it can mess up programs having breaks inside them. So only use it if you really have to. So let's run this again. Is assign I to 1. And essentially running the same code. But instead of having instead of having it end when it gets 6, we're actually going to insert this break code. So if statement I equals 4, it will break. And we'll see what that does in a second. Let's run this. And you can see here that that actually it counts the 1, it's doing what it's doing before, 1, prints 1, goes through here, it hits the if statement, is 1 equal to 4? No, it doesn't activate it, so it goes back to the beginning with the I being increased, hits that, I equals 2 now, 2 is less than 6, it prints out 2, continues on until I actually equals 3, and when I equals 3, it prints out and then goes over here. I is added to by 1, and suddenly I does equal 4. So now this if statement is true, and it will activate. And then when it activates, it runs the code inside its brackets. The brackets, its code is break, so it just breaks out of this while circle. You can use this, it is functional, but it is not the best coding practice to use it. So try to avoid it when you can. So now let's move on to the next statement. With this next statement, we can skip an integer without terminating the loop. So basically you can move on without it actually doing anything. So let's run this. And what we're going to do here is we're going to run this code and it's going to return first. It's going to print 2 because what's happening is, well, it's going to print 1. It's going to run through here. I is 0 at the beginning. 0 is less than 6, goes through here. It has I plus 1, so I is now 1. If I is equal to 3, it activates this if statement, but that's not happening. Goes through here, gets printed, prints 1, goes through here again. Now it's 1, 1 is less than 6 still, goes through here, becomes 2. Is 2 equal to 3? Nope. It continues, and then finally it goes back up here. As this is 2 greater than 6? Nope. It gets added to, now it is 3. It hits this if statement, and then the if statement activates because I is equal to 3 now, so this is true. So the if condition is true, so if is activated, and the brackets and the code in the brackets run, and the code in the brackets is next, And then next, then actually ignores the rest of the loop. So like this print is ignored, and it just kind of just goes back. It just goes back to the beginning. So you can see here, it just like essentially skips 3 in this number sequence. All right. Now we got the while loops out of the way. Let's talk about for loops. And what for loops are is that they take a bunch of values and they run them through the code together. We actually talked about this earlier before. So basically, for and then a bunch of values that you want to run through the code. So in this case, you assign the value x and do 1 through 10, and then you print that. And just run this. We did this before. Let's run it again. So first x is assigned to 1. It goes through. It gets printed. Printed as 1. Oop. And then x is assigned to 2. It gets printed 2. And you can just see it keeps on continuing this process. So there are these things called character lists. Lists are like what it sounds like. It's just a list of things. And for example, we have a list of apple, banana, cherry. Let's assign it. All right. Then, so now fruit here, you can see here, up here, is assigned to this list. And it's just a list. It's just a sequence of variables all bunked together inside one variable. And then we're going to run the for statement. So x in fruits. So x is going to first be applied to apple, and then it's going to run through here and get printed, and the apple's going to be printed, and that's going to be assigned. Then x is going to be assigned banana, and then banana's going to be printed. Let's just see here. All right. And then once again, you can have nested loops just like you can have nested ifs, and you can have actually nested whiles. A lot of programming is actually nesting things. So let us adjusted list, and then fruits, and then it's going to run first this and then this in it. So it's first going to run x adjusted, and then also run another loop inside it, and then it's actually going to run, and then if both values are going to exist in this local loop function. So let's run that, and you can see here it's going to print red apple because it's going to take the first variable from the first part of each list and run them together, and then it's going to say big banana, and it's going to say tasty cherry. All right. Well, that's everything I wanted to cover today. It is a lot. It is all the basics of R. And since it's a lot, all I want you to do for your homework is just go through this yourself again and run the code and just get R installed on your computer and RStudio and just get familiar with it. All right. All right. Thank you for listening, and next lesson we'll learn something that's more practical. But we need to learn this first. Thank you. Bye.